Hey, what's up, everyone? So we are back with another exciting data science project. So in this series, we will analyze housing prices in Bangalore. So this is part one, okay, where we'll focus on loading the dataset and performing initial exploration. Okay, so let's dive in. So this particular dataset, which we have over here, got information about properties in Bangalore, such as the area type, as you can see over here, location, as you can see over here, okay, and number of bedrooms, also 2 bhk, 4 bedroom, 3 bhk, whatever, okay, and also size in square feet, you can see over here, and price in lakhs, okay. So by the end of this series, we will uncover trends and patterns that could help understand the real estate market better. So without wasting any more time, so let's start it. Okay, everyone. So first thing first, we have loaded the data over here, as you can see. Okay, and then we have all the further details in our data set. Okay, which contains details like area type, availability, location, size, and total square feet, and price in lakh. So our goal is to clean, analyze, and extract meaningful insights from it. Okay, so now as you can see, I've already imported Pandas as PT, NumPy as NP, and also imported the dataset over here, okay, using red underscore CSV. And so now we have loaded the dataset, and it's going to give us the sneak peek of what we have over here using df.head over here. So it's going to show us the first 5 rows or first few rows, okay, as you can see over here. And also by dataset shape, we can come to know how many rows and columns are here. Okay, so as you can see, there's 9 rows and 13,320 columns. Okay, and so now further we will be inspecting other cleaning operations. Okay, so this was all about it. So see you in the next part. Okay, everyone. So now that we have explored the data, we will clean it by handling the missing values, removing duplicates, and preparing it for analysis. So first thing first, we have used group by, df.groupby over here. So you can see what it does. It groups the data set, that is df, by the area underscore type column over here. Okay, and so it counts the exact number of occurrences for each area type. So built up area 2418, carpet area 87 times, plot area 2025, super built up area 8790. Okay, and there's also another method of doing it, which is equivalent alternative of it. It is by using df bracket area type dot value underscore counts. You can do it in that way also. Okay, so now moving on. So now we got another similar around cleaning command over here. So in this particular thing, we will be missing values, using helping in identifying missing values, which can distort our analysis. Okay, so we'll handle this issue in 2 ways. First, by filling some values with default data, and then simply dropping it. Okay, and so yeah, you can see over here we have used both methods over here. Okay, and so explaining why unknown and not available are suitable placeholders for these columns. Okay, and then for critical columns like location over here and total square feet, total underscore square feet, we can't assume missing values. We will drop rows where these values are missing. Okay, so you can see we have already done that over here. Okay, so it's important to retain only complete data for such key attributes, because if we don't retain the key data, the exploratory data analysis won't be able to be that efficient, later on. So now we are removing duplicates as this function suggests. We will be removing duplicates with it over here. Okay, and so we will remove any duplicate records to ensure we are not analyzing any redundant data, any useless data. Okay, so duplicate records can lead to misleading analysis further, so that's why we should avoid it. So you can see how many records are remaining after removing all the duplicates. You can see over here around 1 to 790 columns and 9 rows. There were a lot of columns earlier. As you can see, we have identified earlier 13320. So now, after removing the duplicates, 1 to 790 columns remaining. So finally, let's check the shape of the duplicates removed, which is 1 to 790. We have already done that. Okay, so now that's great. I think we have concluded the second part of it. So great, our data set is now clean and ready for analysis. So in the next part, we will visualize and analyze the data for insights. Okay. Hey, what's up everyone? So now we are at the final part of our project. Okay, so this is the visualization part, and we're gonna export the file further. Okay, so the ability to analyze real estate prices is not just about numbers, it's also about visualization. It's also about understanding the patterns, behaviors, and incentives, which are shaping the market. So so you can see I've already visualized price distribution over here using his plot. And so you can see we have examined the distribution of property prices over here. Okay, price distribution is done over here. Because if you don't understand how prices are spread across different properties, you don't really know what you're dealing with. So look at this. What do we see? So what do we see over here? We see that prices are not uniformly distributed. Instead, they follow a pattern, the density curve. This smooth line overlaid on histogram tells us where the prices cluster, where they tap off. Also you can see there are properties for the most part which are in the budget range, and also there are properties which are at the higher end. As we move towards the higher end of the pricing, the number of properties decreases because there are very few properties at the higher end. Most are in budget, but few are luxury properties. And this is also skewing the distribution over here. And this is crucial to understand before making any serious analytical decisions further. Okay, and so yeah, now moving on to the next visualization, which gonna help us in identifying the most expensive locations in Bengaluru. So I have grouped by location and price over here, you can see. And yeah, so you can see average price in lakhs also over here on the left side. And at the bottom, you can see the areas. So Cuban Road got the expensive houses over here, most expensive houses. And 5th block Jayanagar got the least one. And you can see Ashok Nagar is more expensive compared to Srinivas Colony over here. So this bar chart reveals the top 10 most expensive locations in Bengaluru. And look, some locations are dramatically more expensive than others because of the proximity to business hubs, better infrastructure, or societal prestige. Could be anything. So these are deeper questions we need to ask because as I've already told you, that data is not just about numbers. It's also, for the most part, a reflection of human behavior and economic forces at play. But this is a beginner project, so you don't have to do that much of deep analysis over here. This project is just for beginners. But in further projects, you have to keep in mind, because data is, as I said, again, I'm saying it is not just about numbers. It's also about human behavior and economic forces at play. Because what could be the reason why Cuban Road got better or expensive houses compared to Srinivas Colony? There would be a lot of reasons. Infrastructure would be better. More proximity to business hubs, societal prestige, could be anything. So now moving on to the final part, which is final visualization, which is correlation. Correlation heat map. Quite interesting one. So this will show you the invisible relationships in data. One type of data would be dependent on other type of data. So now this part is where things really get interesting. Correlation. It tells us how different numerical factors are related to each other. As I've already discussed, are houses which are bigger always more expensive? Does the number of bathrooms correlate with prices? Now, if a house has 2 bathrooms, is it costlier? Is it more expensive compared to the house which got only 1? So this type of visualization would tell us relationship between data. Now, it's just not a bunch of colored squares. It shows us relationships between different numerical features, not just a bunch of squares. These are relationships between different numerical features. A strong positive correlation means one variable increases when other does. If you could say, if there are more number of bedrooms, the price would be more, the bathrooms would be more. If the infrastructure is better in one particular area in real estate, the price would automatically be better, costlier. If infrastructure is not good, then of course infrastructure is negative, infrastructure data is negative, then of course prices won't be that much. A strong negative correlation means one decreases while the other increases, also. And so you can see the different squares, okay? But the key insight here, not all relationships are linear, So correlation doesn't always mean causation. So you have to keep in that mind also. So if there's positive correlation, then one variable increases when other does. A strong negative correlation means one decreases while the other increases. Okay, so you have to keep in mind. So now moving on. So we got our file, our data set over here. So now we are about to export our clean data finally. Okay, so once we have cleaned and analyzed our data, what we're going to do, we're going to save it, because a serious data scientist or anyone who respects their work doesn't leave things unfinished. So you have to finally save it over here. So I've already saved it. Okay, this is going to be saved so that I can analyze further or improve it later on or add more visualization. Okay, so that's it. We have explored, visualized, and preserved our data. So this is how you structure your workflow. This is how you do real analysis. And this ultimately is how you extract meaningful insights from raw numbers. Okay, so thank you.